I begin share my screen. Hello, everybody. Thank you for joining this session. I am Marco Consolaro, as you can see in the title of my presentation. I am the co-founder of Alcor Academy, together with Alessandro Di Gioia, which is here with us, and together with
Good evening, everyone.
Together with Alessandro and Pedro Santos, we are the co-authors of Agile Technical Practice, this still award-winning book. This talk is titled to TDD or not to TDD. That's the question, which is obviously coming from Shakespeare. Right? And to answer this question, I will tell you a story. The story happened here in the UK in a very big corporation, a financial institution, a German bank, but in the offices in the UK. And it is a story of ordinary madness. It was the story of a big team, actually two big teams, more than 30 people, two big teams. And when I joined, they were working for 20 months. But I've learned as soon as I joined that they did 0 deployments. And at that point, I was like, what? As an expert software crafter, you have been hired to help the team. But as soon as you join, another bad news come. And just a few weeks down the line, the project has been red flagged, which in that company means it will be defunded in 6 months. Well, yeah, I was kind of expecting that, right? 20 months without deployment. So at that point, mission impossible. What would you do? This story, I tell you how they were able to go from 0 to hero in 6 months. This is the real story of how it happened using TDD, but also much more. So let's start. Once upon a time, there were 2 software crafters for saving the project. There were 2 people in that team. When the news of the project being red flagged, they didn't want to give up, right? Everybody else in that team was like feeling doomed. They were starting already to clean up their CV. They were, okay, red flag, let's go. Call the recruiters. They were already preparing to go. But these 2 crafters, they told that in 6 months, you do a lot of things, right? Why do you have to feel doomed? So they started to look at the project and they realized that there was still a piece of backlog that wasn't touched yet. It was upstream. It would have been done before, but it was the boring stuff. So people didn't do it yet. And they were like thinking, if we are able to try and get the hands on that backlog in 6 months without the mess of all the big teams, we might actually be able to deploy something. And so they went to the management and desperation made the impossible possible. The management was desperate and gave them the ability to try the new backlog. The management actually say, oh, we have still budget for 2 extra people. You can hire more people, do it as soon as possible, do anything you can to try to save the project. So they started, and they needed a great team, right? They were just 2, they needed more people, but there were a lot of challenges, right? They wanted to work in a certain way, and that big team was challenging them. And so the first challenge is, do you really know TDD? Or Jimi Hendrix will say, are you experienced? Because in that team, everyone pretended to know its own version of TDD. If you ask them, are you doing TDD? Yes, yes, of course. But then you go to each one of them, and each one has his own idea of TDD, and that was a big problem. Because if we cannot agree about what is TDD, how can we perform it as a team in an effective way? And here it's a little bit like this scene from Karate Kid.
Ready? Yeah, I guess so. Nelson must talk. Walk on. Walk right side. Safe. Walk left. Safe. Walk middle. Sooner or later, get the squish, just like grape. Here, karate, same thing. Either you karate do yes, or karate do no. You karate do guess so. Just like grape.
So if everyone knows TDD, guess so, what could possibly go wrong? And here is the point, right? So what is TDD? TDD is a technique that has been invented a while ago, but it has evolved with time, but its definition has not. And this is a problem because we risk to don't understand each other when we talk about TDD. So what is TDD? Let's see some history, right? TDD is evolved. Where did it start from? Well, it starts from some ideas of Dijkstra, 1970. Quote from Dijkstra: if a developer adheres to the discipline to produce the correct and proof as he programs along, he will produce program and proof with less effort. But the problem that had Dijkstra is that at this time they use punch cards to do the proofs and also the program. So obviously to create the proof before the program was not an easy task. Furthermore, he started to work on the formal proof. And the formal proof is something that is not as easy to achieve. But from there, then came Kent Beck in 2002. Kent Beck's father was a software developer and had a lot of books about software. And among those books, there were a lot of books that came from the idea of Dijkstra. And so Kent Beck was reading these books. And when he came to do the job, actually software has evolved, and it was not anymore necessary to have a punch card in order to get the correctness proof. You could just write a framework, and with the framework you could write the tests just with code. And this is what enabled him to actually create the first version of TDD as we know it today. But still, TDD doesn't answer all the questions, right? TDD is a process to move forward step by step and guarantee to yourself that what you have done so far work exactly as you think it does. It doesn't tell how many tests do we need. The answer, well, the answer is up to you. How big or small the units? Well, TDD says it's up to you. And where do we start from? Guess what? Also here, it says up to you, right? So it is a very well-defined process, but it's just a process. So you need to apply it based on the context. And that's where experience matters. Here, I think the most important heuristic that Kent Beck itself gives is how many tests do we need? And the answer is as few as possible. As far as we have a satisfactory level of confidence that the code does what it's supposed to do. Here, the point is that if we go along the line of formal proof, we might never reach it, right? Because perfection on the proof is really, really hard to achieve. But we can use what I call the Pareto heuristic, right? Which is based on the confidence we have in our test suite. So if the effort is on the X and the confidence we have is on the Y, we can find a point where we have a good enough confidence. And here is the Pareto magic. If we find this point, we will realize that with 20% of the effort, we can have a good enough test rate. And the more we move away from that 20%, we have a diminishing return on our test. We are testing essentially something that is already tested in our test cases. And this is the Pareto principle, right? 80-20 rules, but it's also an agile principle, right? Simplicity, the art of maximizing the amount of work not done, is essential, right? So here is the problem with TDD. If we overdo it, then we have different kind of problems. We have difficult code to refactor. We have to move a lot of tests every time we refactor. If we don't do enough tests, we are not sure that our code does what it's supposed to do. So there is a gray line here on the optimality of the number of tests, which is very hard to tell beforehand. Every situation needs to be assessed, and we need to find this good enough point. So the first crafter wisdom is steady progress, not perfection. With TDD, we can go small, and that's what allows us to be faster in development teams. So it's a little here. The morale is that delivering fast is not about top speed. Delivering fast is about continuous, steady progress. But after the classic TDD came the London School, right? And the London School tried to answer the other two questions. How big, small the units? And where do we start from? The London School is also called acceptance test driven development, and comes from a great book by Steve Freeman, Nat Price, 2009, Growing Object-Oriented, Guided by Text. And the two questions they want to answer is, where do we start from? They say, we start from the user. So from outside to the inside, following the user journey. Why is that important? Because we don't do software because we like to code. We do software because somebody wants to use it. So the goal of every software is to make the user happy. So if we want to do exactly what is best for the user, we need to start from the user. And that's how acceptance test driven development came to be. After Steve Freeman, actually more or less the same time, a little bit of Steve Freeman, there was Dan North that came out with the idea of behavior-driven development, right? Essentially, what the North says is that if we find a way to capture these criteria, these acceptance criteria of the business in a well-defined way, we can actually use them to move forward our products in harmony with the business. And so we don't have misunderstanding problems, right? The idea is this one. If we have a great product, the great product is the right product built right, right? It does what the user wants, plus it's built correctly, that it doesn't have bugs, and it does exactly what it's supposed to. If we start to introduce bugs, then we need to understand what kind of bugs we are introducing, right? We can introduce the normal kind of bugs, right? It's bugs of the category 1. We think the code does one thing, but instead it does something else because the programmer didn't code it correctly. But that is just one category of bugs. With classic TDD, we actually are able to reduce these kind of bugs and almost eliminate them. But then we still have a lot of different kind of bugs, no matter what. And the other kind of bugs are bugs of different category. Category 2 is when the requirement is incorrect or incomplete. And the code is correct, but it's irrelevant. If the requirement is wrong, it doesn't matter how the code is. And then we have the category 3. Category 3 is when the requirement is correct, but it has been misunderstood by the developers. So the code does something else. Now, with TDD, we solve the bugs of category 1. But bugs of category 2 and 3 need something else, needs a way to work together with the business in order that everybody understands the same thing. And this is what we have been solving with BDD and ATDD together. And here, this is a quote from Taiichi Ono that says, if it's not possible to reduce the number of defects, he said in Toyota, but for us they are bugs, right? Then there is a lack of ability. If you are not able to reduce the bugs, of course, you're not good enough, right? But if we are able to reduce the bugs, we should be able to get close to 0 bugs, right? Because if we are not able to get to 0 bugs, it means that there is a lack of perseverance. If we are able to reduce them, we should be able also to get close to 0. This is the principle, the idea that made Toyota conquer the market of cars, right? So these two crafters had a very clear idea of what they meant as working with test-driven development. They wanted to work like this, with a user story, right? Which is just a placeholder for a conversation. So we achieve shared understanding. So it's an idea. Then the business analysts, developers, and quality assurance get together and take this idea and write it in form of scenarios and acceptance criteria, right? It's an agreement with the business about what to do using examples, which then we can automate and make them compile and run as unit tests, which becomes our acceptance tests. And then the development team take those requirements and write the code, right? They start from well-defined criteria, and then the criteria becomes acceptance test, and then the tests get implemented with the double loop. The outer loop is the acceptance criteria cycle, and the inner loop is the classic TDD cycle to use as fit, right? Not mandatory. That's how they want it to work. And they try to hire somebody from that team that knew this thing, but they realized that no one would even understand to work like this. So their solution, they hired 2 skilled crafters from their own network. Fortunately, they found 2 people that were available to work, and so 2 extra crafters joined them in a few weeks' time. The problem here is that as Rome was built in a day, neither TDD was learned in one day. It's a great technique, but it takes time and practice to be learned correctly. However, it gives you great rewards. Loosely coupled design, because if you are able to test it, it's a little bit less coupled than if you couldn't. Doesn't mean that it's good, the per se, but it's a step in the right direction about the design. Then an up-to-date documentation about how to use your system. Because if you write the test first, the test, if you write the test also in a readable way, that's very important. Well, then reading the test gives you a big insight on how to use the codes. And the great thing is that that documentation never gets stale because it needs to compile and be green all the time. No more hours spent debugging. That's another great advantage. If a test is read, then you debug the test, and you don't have to launch all the program in order to arrive at the point where there is a problem. Now, business alignment, right? If we capture the requirement in a very clear way, discussing the requirements together with the business all the time and creating these criteria together, we align with the business. And then courage, right? Courage is about deploying. If we have our system covered with these kind of tests and the tests are green, we have a big confidence, then the system does what it's supposed to do. And so we can go live all the time. So the wisdom of our 2 crafter here is hone your craft, but always mind the Dunning-Kruger effect. What is the Dunning-Kruger effect? Well, the Dunning-Kruger effect is a problem that, in my opinion, is very big in our industry. It's the effect that everybody has when is learning something new, right? And the problem here is our ego, our confidence that trick us in believing to be way better than we are, especially when we learn a technique for the first time. And here we risk to be in the peak of our confidence. You can recognize these people because they go in social media and say, TDD is a silver bullet, right? You solve all the problem with TDD. Unfortunately, reality is different, right? And sometimes it strikes and punches in the face. At that time, the risk is to fall in the valley of despair. And you can recognize people in the journey here that goes online and say, TDD doesn't work. Does not work. That's it. Throw it away, right? Because they have been beaten sometimes and then they reject it all. And eventually, these people then get up in the slope of enlightenment until they reach the plateau of sustainability. You can recognize these people because they don't talk about TDD on social media, right? So this is a stats from 349 interviews for a job requiring TDD. That comes from a friend of mine, Steve Kuo, a great crafter from Seattle, which took the time to keep all these stats together. And this is the problem of the Dunning-Kruger effect in our industry. 100% of the people that went into those interviews claim to know TDD because they were job requiring test-driven development Kent Beck style, not even a TDD. 100% claim to know it. 18% couldn't even write a test. 56% of the interviewed can write a test after the code. 24% write a test before the code, but without following the process of Kent Beck. Only 2% were doing TDD correctly as per Kent Beck. So we talk a lot about TDD, but when it's time to actually do it, very few people can do it right. This is the LinkedIn post. Actually, it's a public LinkedIn post with these stats from Steve Kuo, following from great content if you care about software crafting. And here, this is a quote from Alberto Brandolini, which says, the enemy of knowledge is not ignorance. The enemy of knowledge is the illusion of knowledge. Because if we think to know more than what we know, actually, we stop learning. And this is Freddy Krueger, I think, is the Dunning-Kruger effect has been named after this character. So, but that wasn't the only challenge in there. Another challenge was, is TDD enough? And unfortunately, no. TDD is necessary, but it's not sufficient. In that team, everyone was working alone without a shared strategy. And this is a very big problem. Everyone was a loner in that big team. Everyone carved his own context and wrote things in a different way. But, you know, it's not only about TDD. The extreme programming practice are a lot, right? There's a lot more than test-driven development in that team. All these were missing. So our crafter started to put in place the most important one. And they started with continuous integration, right? The team before, well, it works in my machine. They were doing demo with the business from the local machine. But at one point, the business said, okay, let me see the real system. And then the real system, it didn't work. They spent weeks trying to make it work on the server, but in the server it was a different thing. And so it's a problem. We need to demo on the final system, right? And so also here our crafter wisdom, done is when the customer loves it, not when it works in the local machine. How did they want it to work? Well, they set up a very fast pipeline. The business team and the dev works together. They have idea and then put it in the backlog, and then they do acceptance test driven development and they code it. When the code gets deployed, goes in the continuous integration, it gets run on a system for continuous integration in order to make sure that it's working not only in the local machine. And then it gets deployed. And the business team use the deployed system to test it and make sure that it works exactly as they want. And in the meantime, there is a observability system that allows the team to monitor the system, right? You made it, you run it. So they started to do this, and to do that, they started to do the working skeleton. Working skeleton is an implementation that touches all the integration points. And we want to do this early on in our projects because the integration points are the most painful point of our system. And we don't know what problems we might have because with external systems, we are not in control. We can have a lot of assumptions. And so the best thing is to create a very tiny little story that touches all the integration points in order to get the problems to emerge as soon as possible. Because if we have a clean canvas, our system is just integrating without clutter of every functionality in it, it's much easier to understand what the problem is and solve it beforehand. Once the integration problems are solved in the beginning, then usually the system starts to stabilize. That's when you can start to build features on a more stable system and verify that everything works as it's supposed to be. And so also here, the wisdom is automate everything to go to production without effort. Another important part of the XP practice is simple design. And that's what they focused a lot about. Even Dijkstra said before anyone else, right? In programming, simplicity and clarity are not a dispensable luxury, but a crucial matter that decide between success and failure. Right? So this is fast design. We go fast in the beginning, but it's very hard to move on. Right? Good design is simple design, right? And this is a little bit the idea. If we have a bad design, the code becomes messy. And if it is messy, we can't refactor as often. So we always have to take the time and do refactor in big blocks. And that's when we can't really improve the system as much. We just improve it is good enough to carry on a little bit, but then the code start to become brittle again, and then we arrive down the line at a point that it is impossible to fix it because it's too messy. If instead we have a good design, we keep refactoring and we keep it in good shape until we arrive at a point in time where we have a breakthrough in our domain. Once we have enough test cases, enough code, we understand how we can introduce the abstraction in our code that makes our job easy with time and not harder. That's where we start to get faster down the line with time. In that team, our two crafters, the first story took more than 3 weeks to go live because they did a walking skeleton and they started to sketch the design. And so they had a lot of refactoring, a lot of idea. They needed to find the best way to put all the problems together in a way that can sustain a development effort in the future. And the other 30 people in the other two teams, they were laughing at our two crafters at that point because they thought they were doing a useless effort to save something that was impossible to save. And so they were like, oh, look at these two, 3 weeks to do one story and they want to save the project. They were laughing, right? But in 4 months after that first story, our two crafter finished the backlog. They completed it live. And now the other 30 people, they weren't laughing as much anymore. They went there to ask to see the code. Somebody went out, can I see your code? And then when they showed the code, the answer was like, oh, wow, it looks so simple. And that's it. It looks simple, but to make it simple is actually not that simple. Here, the problem is we need to choose what is better. We want a neck today or a hand tomorrow. Because if we need to do a system that will not be touched in the future, it's just a small program that we know we can throw away, well, then we might not need a great design, right? But if we have a big system that we want to use and want to support our user for years, maybe decades, and then we can't do it if we don't focus on our design. So wisdom here, making it simple is not quite simple, but it will pay off big time in the future. Even Dijkstra says simplicity is a great virtue, but it requires hard work to achieve it and education to appreciate it. So our crafter wisdom is improve your design skill, right? But that is not easy, right? Because how many things do we have to actually understand? There are so many. There's so many, right? How can we possibly do it, right? Learn, right? The problem here is that we can't really force people to learn, right? Learn is something that happens, especially when you feel good and you feel in a great environment. So you can't force people to learn, but you can create environments where learning is likely to happen. And this is what I want to promote in every team and every company I work close to. Hire curious people hungry for learning and optimize your environments for learning together. And don't despair, because in a team of crafter, you'll never work alone. In fact, the last technique that they wanted to use was pair and mob programming. In the team of before, people didn't really want to talk one another. They wanted just to stay there with the headset and code away all day without talking to anyone. And that is a big problem, because if we work like that, how can we make sure that we share our strategy and we share a way to do things together in an effective way? The thing is that the whole is greater than the sum of its parts, because what enable the extra value is collaboration. But we can't collaborate if we don't talk to each other. Collaboration is only achievable via communication. And communication is actually intangible, right? Per programming, right? It will go faster if each one of you took one. Now it makes us laugh, this one, because it's clear that that block is too heavy for one person. The problem is that in software development, that is the cognitive load, and the cognitive load is not tangible as well. And that's why we need to be at least in two or more to work together. Because if we are in two or more, we can exchange our point of view and make sure that we are doing the thing in the best way possible. It's always hard to judge by one person alone. And the best way to do that is more programming. But also here, more programming is a technique that needs to be learned. It's not just throwing some people inside the same room. It's about find a process that work in a very structured way in order to build software together. But if we can achieve that, then it's the fastest way to learn as a team. That's why, for me, collaborative programming is one of the best way to improve any software development team. Even Alan Turing say that programming is a skill best acquired by practice and example rather than from books. And what is best? They code together and influence each other by practicing together, right? It's a little bit like learning to drive a car. If you remember when you were learning to drive, you in the beginning, when you went in the car, you had a big checklist in your mind. It's just like, okay, first I need to check the mirror, then I need to put the key, press the right pedal, put the right gear, look outside, look the mirror, look everywhere, and then you do things. But now, when you drive your car, you don't do that anymore. because you internalize that checklist. You don't need to think about the rule anymore because you became an expert on driving a car. You just keep looking outside because looking outside is mandatory because the context keep changing, but all the other things, they come natural to you. And in order to learn to drive is like learning TDD, practice plus quick feedback. In the beginning, you have an instructor that corrects your mistake as soon as you do it, because that's how you internalize the rule quicker. So the wisdom of our crafter here is optimize your work environment for learning together. And this is probably the most important one. But what was the competitive advantage of that team? Finding consensus in the other team was impossible. And so decision was pushed from the leader. And so we do like this because I said so. And so was very, very hard to find people that really are accountable, because they were, oh, not my decision, he chose that. So there was little skin in the game, and that was a problem. Instead, in our team of our two crafters, the competitive advantage was great teamwork. Not finance, not strategy, not technology, says Patrick Lencioni. It is teamwork that remains the ultimate competitive advantage. And that's how they work. In that team, they had to pick one QA and one business analyst that have never seen this technique before. Those two crafters stay to work together. One of the two started to do the walkie skeleton. The other one was pairing with the QAs and business analysts for 2 weeks along to show them how to do the requirements. The QA was like, are you sure you picked the right one? Because I have never wrote a line of code in my life. I was like, well, I'm gonna teach you. You will see, it's gonna be easy. They were super scared in the beginning, but after 2 weeks, they kick the crafter out and say, okay, we learn, we understand, we are not stupid. You can go away, we can do it. Because it's easy once you understand how to do it. Everybody can learn it. And the thing is that when there is trust, you can have healthy conflicts, right? Conflicts becomes nothing but the pursuit of the truth. They attempt to find the best possible answer. And that's what we have to create environment we can discuss about things to find the best answer, to keep the ego out of the way and focus on doing the best thing. And here is a little bit the problem about the reality versus knowledge and versus our mind. The thing is that it's very difficult to achieve a great learning environment in a group of people, right? Because we need to build what we call the collective mindset. And it works a little bit like this. This is about psychology, it's not anymore about technology. So we have a group of people and we have reality, right? And in reality, reality is one, right? Is objective, is the same for everybody. Until here, we agree. There is one reality, but there are a lot of different people that look at the same reality. And then in this reality, there is knowledge. Let's put an example, microservices, right? To put something a little bit ambiguous, right? And the knowledge describe the reality. So also the knowledge is objective because it explains reality. But what is the problem here? The problem here is that our understanding of the reality is very personal. Every one of us had a very different life, very different experiences. And so it's really hard to have the same idea of knowledge beforehand. For example, microservices is something that everybody might have a different idea about. Somebody can think it's about AWS. Somebody else, it's about hexagonal architecture. Somebody even something else. Somebody thinks that it's just like SOA, but a little bit smaller. Somebody thinks it's Kubernetes, and somebody say, oh, I don't even know what that is. So how can we do to expand this understanding? Well, you can expand the understanding through meaningful conversations and experience. People try to explain each other about what they mean with microservices. And after this meaningful conversation, people start to have epiphany, right? And at the end, if the group has trust, they come out with the same idea about microservices, putting together all the different understanding and create a greater understanding for everybody. So also who didn't know what it was can grasp insight about it from everybody in the group. And this is what we call collective mindset. Collective mindset are the beliefs, the assumption, the habits, and attitude that a group as a whole holds in common about its context. Right? So if we are able to have a big and strong collective mindset, the group is going to be very cohesive. Instead, if everyone goes by itself and have a different belief, we have such a fragmented collective mindset that is basically impossible to find any consensus. Bob Marshall said that it's the collective mindset of an organization that determines its overall effectiveness, productivity, and degree of success. Essentially, the winning equation is a function of the collective mindset. So, let's close. Let's answer the question. To TDD or not to TDD? How do I answer? Like Kent Beck. Up to you. But if you do, first learn it properly, right? And always remember that it's the ego that is the ultimate killer of a team, right? That's your ego. So Steve Jobs once say, stay hungry, stay foolish. I rephrase it. I will say, stay hungry, stay curious, but for God's sake, stay humble. Thank you. And here at the end, I do some advertisement, right? There's our software crafting public training coming on, organizing collaboration with Advanced Coperta. It's one of our training open for the public. Usually we do this training only through the companies, but in October and November, we have a training program coming up with Advanced Coperta open to the public. So if you go in the website of Advanced Coperta with this QR code, you can find, I think, early bird tickets are still available. So hurry up and thank you again. Now, if we have
a question.
Yes.
From Jenny. She asks, does the Pareto guide you also in critical systems like healthcare, airplanes, for example? What is good enough level?
Yeah, well, that's
You can find it in the chat.
That's a very good question. Of course, every context has its own degree of risk, right? So if I am coding an aircraft or the system for a pacemaker or something that is life-threatening, probably I will try to have a bigger proof, right? It all depends on our context. If the context is risky, the effort we want to put in assure that the system behave as it should, it has to increase, right? But it's all about risk management. I found that in a situation where the risk is not that big, there is no much value in over testing. But there are techniques that can really make our test deep in situation where we need it, right? I think about combinatorial test and other kind of test that allows us to proper test all the possible input. Also mutation test to test that our code is done properly. There are many techniques if we want to go deep, but I believe they are depending on exceptional context that we don't always work in the everyday jobs. Other questions?
I think there's no new questions, so we can go and have dinner.
We were perfectly in time. So thank you very much to everybody that are here. There's a new message. Let's see. Thank you for all the feedback in the chat. I see it has been appreciated, so I'm really happy about that. Thank you for being here to listen to me and join our training if you actually want to learn these techniques. We have a training program that is meant to teach at least what we can in 10 episodes about these techniques. I'm sure it's more than enough to show your colleagues a few new tricks that will have a wow effect. So I believe it's time to close. For who is near a pub, enjoy your pint. Otherwise, enjoy your dinner with your wife. It's time. Have a good evening.
Thank you so much, people. Have a good evening. Thank you.